Hello again. We are back doing more fun pre-calculus. What's more fun than that? Nothing. And today we're going to do chapter 4.3, which is on circular functions. And so it's still going to be sines and cosines and tangents and all of that, but it's using a circle and you'll see how that's going to work. So let's get a new page here. And first of all, let's talk about, oops, am I not? Oh, my thing's not right. Hold on. I got to adjust what screen I'm writing on because I have a second screen and the drawing tablet is linked to that one. Okay. Uh-oh. There we go. There we go. Okay, so first of all, you need to remember the standard direction of angles is that way. That direction is positive. Any angle in that direction is positive. Any angle in this direction is negative. So it's really important to remember that, okay? So if you're given theta equals 170 degrees, well, positive, so it's in this direction, 90, 180, so 170 would be here, which would make this 10 degrees, right? Because they're going to add up to 180, because this goes 0, 90, 180, 270, 360. And it's also important to remember, let's get some dark green action. There we go. It's also pi over 2 pi. That's not a very good pi. Oh well. 3 pi over 2 and 2 pi, right? In radians. Those are the axes, and we have to always keep those in mind. Okay? So now let's say we want theta equals negative 170. How do we draw that? Well, negative is in this direction. So I'd go 90, 180, so same thing. Right here is negative 170, and that would make this, I guess that'd be 10 degrees. So these are referred to as the reference angles. Those are the angles relative to the axes. This is the total angle, 170. Okay, I just want to remind you of the rule for the direction of the angles for their sign, positive or negative, not their sign as an opposite over hypotenuse, which is totally confusing. Okay, now, if we want to use the angle, let's say, I don't know, 13 pi over 2. Well, that's a big angle, right? That's bigger than 2 pi, because 2 pi would be equivalent to 4 pi over 2. That would be all the way around, would be 2 pi or 4 pi over 2. This is way more than 4 pi over 2. And so this is a whole bunch of times around the circle, and then you stop somewhere, and this is your final angle right here. And so we need to figure out what that is, and there's a strategy for that. First of all, I look at this, I see 13 pi over 2. Well, I'm going to take a pi over 2 out of there. I'm going to make it 12 pi over 2 plus 1 pi over 2, right? That's just adding fractions. That's legal, right? So, 12 pi over 2, that can be reduced. 12 over 2 is 6. 6 pi plus pi over 2. So 6 pi, let's see, once around is 2 pi. So twice around would be 4 pi. 3 times around would be 6 pi, and then we have this extra little bit. So here's where we would end. So 13 pi over 2 is this, and that's really an angle of 90 degrees, right? Really, we went 90 degrees, but we did 3 times around and then did 90 degrees because pi over 2 is, I want to keep reminding you, 0, 90, 180, 270, 360, and 0, pi over 2, pi, 3 pi over 2, and 2 pi. We got to keep remembering those. So we did 3 times around and then an extra pi over 2, an extra 90 degrees. So we ended up on the positive y-axis. So there's one where we had to figure out what the angle was that we're really talking about, because 13 pi over 2 is not helpful. Pi over 2 is helpful. Okay, let's take another one. Theta equals 5 pi over 6. Well, we want to compare, we want to see how many turns there are in here. So how many pi's are there? Pi would be halfway. How many 2 pi's are there? 2 pi would be all the way around. And this is closer to pi than 2 pi, right? So I can write this as 6 pi over 2 minus 1 pi over 2, because I can see this is closer to 6 pi than it is anything else. Oh, I guess that's not right. We could do, oh, I should have done 4, oh no, it's over 6. So I was right, and I erased it for no reason. No, let me just do it again. Because it's not over 2, it's over 6. So I'm going to write this as 6 pi over 6 minus 1 pi. There we go, over 6. Because 6 pi over 6 is pi. So this is going to be pi minus 1 pi over 6. So how much is that? So pi is here minus 1 pi over 6. That would put us here at, this angle would be pi over 6. And if we try to convert that, pi over 6 times, I'm going to convert it to degrees, 360 over 2 pi. Let's see, the pi's will cancel. I'll get 360 over 6, which is 60 degrees. So that makes this 60 degrees. Oops. Let me choose a different color. 60 degrees. What am I doing? Okay, sorry. Let me do this again, because I wrote the wrong stupid thing. There. Because 6, that was not right. So over 6 now times 360 over 2 pi. Cancel, cancel. We get 360 over 12, which is equal to 30. There you go. That makes more sense. So this is 30 degrees. And that makes this 180 minus 30 is 150 degrees. But we could have just taken this and converted it just like that from radians to degrees. We would have gotten 150. So I subtracted off a pi because this is closer to pi than it is to 2 pi. Okay? Let's try this. Oops. There we go. So let's do theta equals 15 pi over 7. What's that? Well, let's see. Is this closer to pi? So I guess it's over 7. So is it closer to 7 pi over 7? Or is it closer to 14 pi over 7? So that'd be 2. If I wanted it to be 3, it would be, oops, not equals. It would be 21 pi over 7, right? 7 over 7 is 1. 14 over 7 is 2. 21 over 7 is 3. So I'm looking to see which one this is closest to, and it's closest to 14 pi over 7. So I'd write this as 14 pi over 7, and I'm 1 bigger. So that'd be plus 1 pi over 7. Okay. Oops. There we go. So 1 pi over 7. So 14 pi over 7, that's 2 pi plus 1 pi over 7. So 2 pi would be all the way around. So it would be all the way around is 2 pi and then 1 pi over 7. And that's a tiny thing. That's less than pi over 2. So it's somewhere in here, right? This would be pi over 7. And again, pi over 7 times 360 over 2 pi. Cancel, cancel. This ends up with being 360 over 14, which is not a convenient number. 180 over 7. I don't know what that is, but it's a number. So we can calculate that angle. So we want to discard the part that is not necessary, which is the multiple loops. And we want to find out what axis is it near so we can actually draw the angle that we need, like pi over 7. Okay? So you'll have problems where it asks you to find the reference angle. And finding the reference angle means take out the extra loops around in a circle, just like we just did, and find the piece that's left over. Okay? You'll see that on the homework. However, we'll do more of these during office hours so you can see how these works. So now let's say we're given the point 5, 3. And I want you to find what sine theta equals, cosine theta equals, and tangent theta equals. Well, we got to first draw a picture. 5, 3, 1, 2, 3, 4, 5, 1, 2, 3. So we're going to be here at the point 5, 3. So I'm going to draw a line, and whenever possible, make a triangle. Its height is the y coordinate, 3. Its base is the x coordinate, 5. Its hypotenuse would be 5 squared plus 3 squared equals c squared. So 25 plus 9. So 34 equals c squared. C equals square root of 34. Are there any perfect squares in here? No. It's 17 times 2. Those are the factors, no perfect squares, so that's already simplified. So the hypotenuse is square root of 34. Okay. So now I can go to sine. Here's my theta. It's always measured from the x-axis. And it's measured in this direction, right? It's a positive number, so I know it went in the positive direction. Well, I don't know that. I just know the coordinates are in the first coordinate. So that's how we would draw it. So sine theta would be opposite over hypotenuse. And you're probably saying, no, Mark, you can't do that. You have to rationalize the denominator by multiplying by square root of 34 over 34. I am so proud of all of you for knowing that. That is excellent. So this will become 3 radical 34 over 34. That's the right answer. Cosine is adjacent over hypotenuse. So that's 5 over radical 34. And tangent is, oh, what? I still have to rationalize the denominator by multiplying by square root of 34 over square root of 34? Okay, if you insist. So 5 radical 34 over 34. And lastly, tangent, opposite over adjacent, 3 over 5. We don't have to do anything. Yay! And if you wanted to do cosecant theta, well, I would take my original thing, 3 over radical 34, and just flip it. Because cosecant, there we go, cosecant theta is equal to 1 over sine. Since it's 1 over sine, you can just flip it. Let me move this. I don't know if that does anything or not. And let me move you. There we go. Okay, so 1 over sine is just taking it and flipping it over. Secant theta, which is 1 over cosine, I'll take the original thing again and make it square root of 34 over 5. And tangent theta, cotangent theta will be 1 over tangent. So tangent was 3/5, so 5/3. So those are the 6 trigonometric functions. I think this is one of the easiest problems you can get, finding the 6 trigonometric functions. Students hate it. I don't get it. But you should make sure you're good at doing this, because certainly you're going to need to do that sometime. Okay. Given the point P, is negative 5, 3. Oh, let me write that a little neater. What's all the 6 trigonometric functions? So you're probably thinking, well, shouldn't I draw a picture first? And you are exactly right. So over here is negative 5, 3. So again, we'll draw a triangle. And I know this side is 3, and this length here, I'm going to use negative 5. It's very, 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 very important you include that negative sign, or you're going to get some minus sign errors. So include that. And when I do the Pythagorean theorem, minus 5 squared plus 3 squared equals c squared. I don't really care about the negative because it's going to get squared. 25 plus 9 equals c squared. 34 equals c squared. C equals radical 34, just like before. So now sine theta. So here's my little theta. Really, this is my theta, but I'm going to use it here to do opposites and adjacents, and I'm going to remember we're in the second quadrant, and in the second quadrant, the x coordinates are negative. Here's the first quadrant, here's the third quadrant, and here's the fourth quadrant. In the second quadrant, y is positive, but x is negative. Okay, so sine theta, opposite over hypotenuse, which, just like before, 3 radical 34 over 34. Cosine theta, adjacent over hypotenuse, negative 5 over square root of 34, which will give us negative 5 radical 34 over 34. And tangent will give me opposite over adjacent, 3 over negative 5, which is minus 5/3. Oops, negative 3/5. We don't have to do anything. But I'm not going to leave the negative in the denominator because that's just weird. So I can multiply top and bottom by negative 1. So let's do that. So if I multiply by top and bottom by negative 1, this will become negative 3 over, and minus times minus is plus. You can actually move a negative sign up and down to the numerator or denominator as long as there's only one thing there without a problem. You can't do x minus 2 over 6 and move that negative down here and say this is equal to x plus 2 over negative 6. I would say nay. You cannot do that. Nay. Never do that. It makes me sad. So if it's just one thing in the fraction, then you can move it around back and forth. Okay, what's 1 over sine? Is that secant? No, that would make too much sense. It's cosecant, the opposite from what you expect. So that would be 1 over sine. So that'd be radical 34 over 3. Secant theta, 1 over cosine, this flips. Radical 34 over negative 5. We're not going to write it that way. Negative radical 34 over 5. Or maybe you want to put the minus sign out here. I don't like doing that because sometimes I write them too close to the division line and I forget they're there. So I like to write them in the numerator, but you do whatever you want. You do you. Okay, cotangent is 1 over this, so that'd be 5 over negative 3, so negative 5/3. See how it almost looks like a divisor sign? That's why I don't like doing that. There you go. I'd rather do that. Okay, same problem. You just had to keep track of this negative sign because notice cosine, tangent, secant, and cotangent all came out negative. And there's a pattern for when they're going to come out negative and when they're going to stay positive. And here's the pattern that some of you know. So first quadrant, second quadrant, third quadrant, fourth quadrant. All students take calculus. This is how we remember the pattern. In the first quadrant, all functions are positive. In the second quadrant, sine is positive. In the third quadrant, tangent is positive. And in the fourth quadrant, positive. And in the fourth quadrant, cosine is positive. Okay, so if you got an angle in the first quadrant, sine, cosine, tangent, secant, cosecant, cotangent, better come out positive. Over here, if you have an angle between 90 and 180, or between pi over 2 and pi, sine better come out positive, or cosecant, right? Because cosecant is 1 over sine. These better be positive, and all the rest of the trig functions better come out negative. And that's what happened in the last problem. Sine and cosecant were positive, cosine, secant, tangent, and cotangent were negative. Down here, tangent's positive and cotangent, because it's 1 over tangent. And over here, cosine and secant theta are going to be positive in the fourth quadrant. So we need to make sure we always keep track of this and watch what we're doing to make sure we hit that. Okay, so we did that, we did that. Okay. That's not what I wanted to write. Given sine theta is equal to 3/7. Find all 6 trig functions. Okay, going to draw a picture. See, sine is positive, so it could happen in the first quadrant or the second quadrant. So we don't know, so I'm going to assume it's here. Here's theta. And this would be opposite over hypotenuse. 3 squared plus x squared equals 7 squared. 9 plus x, oops, let me write that. That was rather messy of me, I apologize. Plus x squared equals 7 squared. So 9 plus x squared equals 49. Subtract 9 from both sides. X squared equals 40. X equals square root of 40. And square root of 40 can be written as 4 times 10. 4 is a perfect square. So I could write that as square root of 4 times square root of 10. So this is 2 radical 10. That's how we need to write that. Okay. So we now know the sides of the triangles. Sine theta, we know. Cosine theta, adjacent over hypotenuse. So that'd be 2 radical 10 over 7. Tangent theta is opposite over adjacent. 3 over 2 radical 10. What are we going to have to multiply by to rationalize the denominator? We don't care about the 2. We care about the square root of 10. So we got to do that. So this would be 3 radical 10 over square root of 10 times square root of 10 is 10 times 2 is 20. Okay. And then cosecant is 1 over sine. So it's going to be 1 over this. So it'll be, oops, I wrote that wrong. That should be a 7, right? So that should be 7 over 3. And secant theta is 1 over this, 7 over 2 radical 10. And again, multiply by radical 10 over radical 10. We get 7 radical 10 over, that gives me a 10 times 2 is 20. And cotangent theta is 1 over tangent. So I could just do 1 over that, right? Would that be right? Yeah. So, because I don't want to flip this, because if I flip this, then square root of 10 ends up in the denominator, and I got to rationalize again. So I'm going to use this, the original one. 2 radical 10 over 3. Ta-da! Now, if it was over here, it would have been correct to say if this was theta, sine would still be 3 over 7. So we don't really know where it is. If it's over here, so this is still 2 radical 10, but it would be negative. So if it was in the second quadrant, then all of these 2 radical 10s would be negative. And so you'd have a whole bunch of negatives here. Because over here, only sine. All students take calculus. Only sine would be positive. All the others have to be negative. Very, very important. So folks, so remember that. You always got to think all students take calculus. Very important. Okay, so let's see. So if I have point P and a radius of 4, can you tell me what the 6 trig functions are? Well, let's see. I don't know what theta is, but I know it's in the second quadrant here is point P. So that means X is going to be negative here. So to do this, so here's my Y and here's my X. I'm going to use sine theta, opposite over hypotenuse. No, we're missing something. We can't do that. Oh, okay. Sorry. We're told this is pi over 3. And let me look at something for a minute. So if it's pi over 3, I really prefer to work in degrees. You can switch your calculator to radians and this will work fine. But I'm going to switch to degrees. So this would be 360 over 2 pi. I do it this way because I want the radians to cancel so I can get degrees out. Or, I'm sorry, that's not the way I want to do it. I could do it, the other way to do it is, so that is it. You can do it that way. The other way is to use ratio. 2 pi over 360 equals pi over 3 over x. And we could cross multiply. So 2 pi x equals pi over 3 times 360. Pi's will cancel. The 2 will cancel here and leave me a 180. So x equals 180 over 3, which is 60 degrees. So I'm going to use in here, I'm going to use 60. But I'm going to remember that x must come out negative. If you want to be certain, you could, if that's 60, this would be 120, right? You could use 120 for all of your things. It's up to you. I'm just going to use 60. So sine 60 equals y over 4. So let's see, what's sine of 60? That's 0.866 equals y over 4. So, oops, gotta switch glasses so I can see the little bitty buttons on. Times 4. Okay, so I get y equals 3.46. Okay, so this is 3.46. I'm going to do cosine of 60 equals adjacent over hypotenuse. Cosine of 60 is 0.5. Multiply both sides by 4. 2 equals x. However, it's in the second quadrant, and I got to remember that this is a negative thing. So I got to put into here -2. Super duper important, that negative sign. Okay, so now sine theta we have is 6, oops. And I'm not going to reduce these. You can reduce them later. Dang it. Come on. Starts with a 3. So there's sine theta. Cosine theta would be -2/4, which would be -1/2. Tangent theta would be 3.46 over -2. So that's going to be a negative thing. And then let's go down here. So cosecant theta would be 1 over that, 4 over 3.46. Secant theta will be 1 over that, 2 over -4. And cotangent theta will be 1 over that, -2 over 3.46. So I had to use here I had to use sine theta to find one of the sides, and then I use cosine theta to find the other side. Okay, and then I'm able to figure out the 6 trigonometric functions. Not terrible. Takes practice. You got to practice. The only way to practice is to do the homework. If you don't do the homework, you're not going to do well. I think that's about it. So that's section 4.3. Come to the homework section, come to office hours, and make sure you know how to do the homework, because you're going to do the homework online and it's graded, and you don't want to make a mistake, and you only get 2 tries to do it, and then you get your grade. So I have found that homework will cost people a letter grade if they don't take it seriously. And so I strongly encourage you to come get help. So please, 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 please come ask for help so you can get it. Okay? Thanks for watching. Bye.